ask everybody a quick question about whether you use Revit. So I'm going to launch that poll. We as the presenters, we can't answer, but we can share the responses right after we get them. Let the majority of people vote here. Looks like we're almost about 3/4 of the people, so I will share the results. So we have about 90% of the people who actually use Revit either themselves or within their organization. So the majority of us, right? And before we do that, before we move on, let's go ahead and ask people what your discipline is. We'd love anybody calling, especially outside of the East Coast, where we are mostly represented. We'd love to hear in the chat where you're calling from today, or just go ahead and throw it in there, right? Love to hear from you guys. And go ahead and share our results. So very typically, majority of us are architecture, but a lot in construction. That's a really, really heavy showing today for construction. So welcome everyone. We'd love to see you at more of these. And of course, you can always check us out on our LinkedIn group and see all of our recording information, as well as all of our PowerPoint slides and other useful presentation information. All right, well, without further ado, pass it right over to you, Steve.
Great, thank you.
Absolutely.
Okay, so before we get started, I like to talk about two different things. First, we're going to be discussing KitConnect, but Project Frog owns KitConnect, and I'd like to just talk about who Project Frog is a little bit. I think it helps us qualify the reasons why we are making KitConnect as a tool that focuses on industrialized construction. So Project Frog is a company that's been around for 15 years. We have a flat pack and volumetric system. We've been building light gauge steel and wood construction projects for a very long time. So about 5 years ago, we created some internal tools and some internal processes, and Autodesk took notice. And this is when Forge Fund was available. And so we were the recipients of some money from the Forge Fund, which helped create KitConnect. So KitConnect was born from the industry and is still maintained and being built by Project Frog, who is still building buildings. So I like to say we're in the trenches, we understand the problems, and this is one of the reasons why we're passionate about trying to release a tool that's specific for industrialized construction. And then there's a couple fundamental things that I like to coach before we get into KitConnect, especially in a 15-minute demo. So I'm just going to talk about kind of the process that one would go through first, and then we're going to talk about some core concepts. So first, we start off with design content. So we have loadable families and we have system families inside of Revit. The next step is, you have an end user that creates a KitConnect library, and there's nothing in it at the beginning. Now, the first step is to get Revit content and to publish this to this KitConnect library. And then once these elements are published, we can then start to arrange them in different configurations, right? And so these can be arranged as assemblies or modules. These are KitConnect terminologies, excuse me. And then we have both, like I said, assemblies and modules, and then modules can have system families nested with assemblies, nested with elements. As long as it's published from the KitConnect library, they ultimately become accessible by end users inside of Revit. Once you have your library, you can clone your library. You don't have to, but if you want to, you can clone your library to kind of create an independent design connection to a specific file. And then from this point on, you just connect your library to as many Revit projects as you want, and then you're going to use that content inside of your file. So we have a library which holds and stores all of our arranged and designed content. And then we have a Revit project, which is attached to a library. As many Revit projects as you want can be attached to a single library. And then we're going to use that content within that library. So I want to make sure we kind of understand that before we jump into the next portion. And so what we discovered in industrialized construction, and then additionally what we've discovered after interviewing multiple customers, is there's a few core principles that I feel like industrialized construction needs to have in order to be successful. And one of those is we need to have structured design, we need to have command and control, and we need to be able to capture knowledge and distribute that knowledge amongst a project team. And so how is KitConnect going to offer a structured design? We're going to do that through a couple different features. First, we're going to offer user controls and permissions. And so if you know Revit, you can get into Revit. Anybody can do anything at any point in time, right? And that's great. This is what the tool's for. It's a great design tool. But what KitConnect is going to do is, as it relates to anything within the KitConnect library, we're going to force behaviors with user permissions. So certain users can author and arrange and design content. Certain users can only configure content, and then certain users can only use content, right? Not edit, not delete, things like that. So we add a layer of user permissions and control as it relates to components that are inside of the KitConnect library. And this is very fundamental in IC. We typically have a DFMA engineer. We typically have someone who might be doing documentation. We may or may not want the person doing documentation to have edit privileges to content that's been engineered and designed for fabrication. Next, KitConnect is going to create KitConnect elements, which we loosely discussed before. Elements, KitConnect elements are just loadable families, system families published to KitConnect, and then we're going to create, we're going to offer a structured design, which is a KitConnect module, and those are simply just arranged elements applied, arranged elements and applied configuration rules with a common insertion point. So it's basically taking KitConnect elements, arranging them, sharing an insertion point of those things so that we understand they have a relationship to each other, and then using them inside of the project. And because we have a structured design, we can then visualize this in a different experience. So we have a web application that is tied to this structured design. So you can see and hold and evaluate the content that's in your library. So we can look at arranged components. We can just look at individual elements. We can get out bill of materials. There's lots of different things we can do because we've got this structured design, if you will. Next, we're going to look at command and control. So what does KitConnect offer for command and control? Once again, user permissions. So user permissions are going to force us to give rules to users that we want to author content. We're going to force users to not author content, just like we had mentioned before. Next, we're going to kind of blaze through a couple videos. We're going to look at our Kit browser here. This is the liaison between our web application and the Revit environment. We're going to simply insert a module here, and we're just trying to show you what this looks like. So we have what's called a super select command. We've inserted some design content. Super select is going to understand that these things have a relationship to each other. And then we're just going to use Revit and all their other translation commands. We're going to super select, move, copy, rotate. But what's really important to understand here is KitConnect is going to offer some auditability concepts. So what I'm doing here is I'm going through as a user and I'm changing this engineered and designed content, right? I've deleted a component, I've rotated an element. And so what I'm going to do is I'm going to select any one of those components and I'm going to say, let's do an audit, or a Git content update is what we call it. And the audit is basically going to evaluate that geometry, say, hey, these things are not proper. We need to force the behavior to make sure that they are back at the original state of which they were designed. So we're going to fix that problem. Next, what we're going to look at is we're going to look at edit. And so edit, we're going to take that same content we just inserted, and we're going to make a configuration change. We're going to change the casework size here. We're going to go into the countertop now, and we're going to adjust the countertop heights to accommodate that new countertop change. And we're going to simply submit this change as the same design, but as a modification to that design. So when we submit this, you're going to see now that it's going to bump to a version 2. And then inside of our project environment, we're going to go and consume that change, right? So, and don't forget, this is any Revit project connected to this library would go and then consume that change. So we're going to do what's called a Git content update. You're going to see these things evaluate the new design. It's going to change those, and we're going to automatically, shrink and change the sizes to this new design size. Just as a quick note for all the Revit users in the room, we are maintaining element ID. So anytime that you come in and you make these configuration changes, any annotation, any documentation, any scheduling features, any third-party data extraction, clash detection, stuff like that, it's being maintained because ultimately we're maintaining element ID. Next, we're going to look at module configuration. So once again, we're going to use our Kit browser here. I'm going to simply insert a different module. And this module is going to be an exterior facade component. So it's going to be, concrete and a window. We're going to insert it twice. You're going to see it pop up in the 3D view over there. So this is just a very simple representation of a module, right? I'm going to use a colorize feature here so that you see that these things are the same. And now what we're going to do is we're going to duplicate this configuration. So the concept here is you're using this almost like a template, right? Very similar to what, a templated family might be, except we're going to take this module and we're going to duplicate it, and it's going to create the same exact configuration. So what I'm doing here is I'm duplicating this configuration, giving it a unique name. You're going to see now that we have two modules pop up in our Kit browser. And before I insert this, I'm going to use our configure tool. And so when I first set this module up, I created some configuration rules. This is called an option set. Option sets are like a Rolodex of parts, or parts like alternate parts that can be used in place of other components. So I've used my configure tool. I'm now going to insert this geometry. And now what you'll notice is it's the exact same configuration with the alternate window that I've chosen within my configuration. I'm going to insert it twice. You'll see it appear in the 3D view with a different style of window. All right. Now we're going to do the exact same thing. We're going to duplicate that same module preset, the very first one. And we're going to do it in a reverse order, though. After we duplicate, we're going to insert, and then we're going to configure. So configuring can happen at any stage in the design or fabrication process, right? Important to note. So we're duplicating this module preset. We're giving it a unique name. I'm going to insert this module preset. And what you're going to notice is it's going to look exactly like the yellow one in the 3D view. And that's because we haven't configured it yet. So we're inserting our module. We're going to do a colorize, I believe, is the next step to show that each module is, to show you what each module is. We're going to take that green module, the third one that we configured, and now we're going to configure it post insertion. Once again, we're just going to simply change the window, and then we're going to apply another rule set, which is called part suppression. We are going to unsuppress a sunshade. We're going to update our module preset, and you're going to see now that those sunshades get added. So modules in configuring is a kind of a core foundational piece of KitConnect. So across the board, we can audit content at the instance, we can configure content on the fly, and then we can edit content, update content. Next, what we're going to look at is another video. We're going to look at some design automation using Dynamo. Additionally, we're going to look at what KitConnect calls level of detail. And then we're going to look at a bill of material service that KitConnect also offers. So
while this is running, or maybe before it runs, Scott, we have a few questions coming in, really, really wonderful ones that I couldn't have come up with myself.
Great. So ask them at any time.
First off, the first question was, do you see any limitations in terms of the Revit scale and its limitations, like the 1/32 or smaller, cannot exceed larger than 30,000 feet, these types of things? Do you see this being a problem in fabrication, and maybe something that Autodesk should look into in terms of these scale limitations? Have you, or has KitConnect?
Yeah, for sure. I've seen that error many times. Yeah. Typically when we model something that's at a really small scale, we model it virtually. I know that sounds weird, but like we'll just say like you have a length of a stud that's say 8 foot long. I'm not modeling fasteners in for that stud, but I know how many fasteners are in that stud because I know a length and I know an offset value for sheathing for that stud. So typically, at least for us, we don't model things to that small of a degree. We model those using conditional formats. Like we know that we might need a connector between two wall panels, but we may not model that because there's nothing that it can clash with. And then additionally, that's just something that we can add as a quantity, not something that has to be evaluated and then quantified, in my experience.
Absolutely. And that's a great way to resolve it, just with the conditional statement. Absolutely. The next question is, it looks like you're dealing with a repository from KitConnect. Is that tied to the main KitConnect library, or is that something that you can make more project specific? Is the versioning tied to kind of your standard library, or is that kind of an offshoot?
No, great question. The library is specific to the version. So whatever your library has is what's going to be distributed to your project. At the end of the year, we're going to be able to have versioning control. So you can consume a certain version or not consume a certain version. But right now, it's a forced version update.
That's fantastic. And what about a user that doesn't have KitConnect? We do a lot, especially on BIM 360, maybe we have a joint venture and an architect that doesn't necessarily have this program, or an engineer who doesn't have this program. How would that work? Would it lock the element in some way, or would it be restrictive in some way in that scenario?
No, not at all. They're just Revit elements. If the user wants to interact with KitConnect components, like move a module, things like that, we have a user tier that literally is just able to select components. And that's a free user tier. So.
And the last one before we get into Dynamo, because I'm super excited about, I'm guessing you're going to let everybody know where they can get all of this software.
Yeah. So yeah, you just need to connect. You need to connect with us. That's it. And then there's 1 or 2 ways that we can set up trials for you guys. Absolutely.
There we go. Get a trial. Get it going.
Cool. All right. So what we're going to see here is I'm going to insert what we call a bounding box. We have 3 different ways to represent geometry and modules here. This box is a lightweight mass. Revit sees it as nothing, basically, or a mass. KitConnect sees all the parts and pieces, right? So Revit, very lightweight, but you can look inside of KitConnect and it's going to tell you all the parts and pieces. I'm now going to switch this level of detail to show all parts and pieces. I'm going to go back into my bill of material, and you're going to see that nothing has changed. So high level or low level, KitConnect sees all components at a full level of detail inside of our web application. I'm now running a Dynamo script. So we've connected most of our features to Dynamo. And so now you can insert modules at a bulk rate at high level or low level and get a full bill of material based on just these boxes, right? I can change these boxes if I want. It's still going to be the same bill of material. I can show all level. I can show part level. But we have exposed most of our features inside of Dynamo because we've got most of the people that we're dealing with have already, they're 3 years into Dynamo automation. Okay, and some of the last things we're going to look at is going to be knowledge capture and distribution. Once again, I'm going to say that user roles and permissions are going to help us here. And then what I'm showing here is just different configuration methods, right? We showed configuration as it relates to the end user inside of the project environment. Now I'm showing configuration as it relates to the end user, that is your DFMA engineer, the person that has the privileges to both edit and configure and create content. And so, we have configuration at the end user level, and we have configuration, the creation of the configuration and the rules within KitConnect. And that's kind of what I'm showing here. As a secondary part here, I've mentioned this a few different times, but this is super important. This is one thing that we've learned at Project Frog as a company that builds buildings is one of the major powers of KitConnect is one library connects to multiple projects. So there's plenty of times where you might have one project that has multiple building files, and there's geometry that needs to be shared between those buildings. The only way to really do that truly is through a link. There's not really any other successful way to continuously edit and change these components and have them all propagate to a Revit file. Do this at a scale, it becomes really hard to manage. So this is where KitConnect is going to come in and really kind of turn into your rock star. It's going to let you control, command, and create and distribute your content in hundreds of different ways. And then what we really like to show here is, with all of these things in conjunction, you're going to get continuous optimization. And this is one thing that Project Frog has really reaped the benefits of, is every single project we do, because we use KitConnect, is going to enable us to go to the next project with the same lessons that we've learned from the previous project, because we're editing it in a library. The next project kicks off, we've got all the lessons learned from the previous one. So we've been able to continuously optimize our building based upon, anything from a cost input, based upon anything from a fabrication input, based upon anything from a user feedback input. So we can able to continuously optimize our building. Each one is going to be, slightly different, but each one is going to be slightly better. Okay, I'll be quiet now. I'll let somebody else go. Thank you. I'd love to answer any questions.
I think at this point we've captured all the questions, but please feel free to throw them through if you guys have any or any come to you. Before we move over to the next presenter, Steve, if you want to pick a winner, this is a big one. You get $50 to give away. Just randomly is fine.
Let's see here. Mark Perry.
Mark Perry. Congrats, Mark. Look at you. You got $50. All right.
Mark, I get half of it. I hope that's okay.
You guys are really chatting on the side, right? Mark sent you a message. Awesome. All right. Our next presenter comes to us with Concrete Pixel. Hey, Dan, how's it going?
It's going well. It's going well. Thanks for having me. Excited to present here. Yeah.
Very excited to have you.
Excellent. Well, my name is Dan Adams, and I'm a design technology specialist, but I'm also a licensed architect who specializes in visualization and technical storytelling. So I'm going to go ahead and share my screen here. All right. So today I'm going to talk about BIM Beyond Design. That's going to be design technology and concept about vertically integrated manufacturing. So before we dive in, I just want to set the stage with an introduction about my approach to BIM. I just want to make sure, can you guys see my screen?
We sure can.
Okay, excellent, excellent. So I have a long-held philosophy since the advent of BIM kind of showed up in our industry, that AEC tech kind of follows a pattern I've referred to as hub and spoke. I really believe that this is the pattern that kind of defines how virtually all design technology is used in practice. The majority of architecture and engineering firms heavily utilize these design and documentation spokes, and construction, the coordination spoke. The other fringe spokes are used to a lesser degree, but still have a very large impact, which is what we're going to talk about today. So over the years, I've seen these fringe areas. There's a big lack of consistency due to variation in skill sets, different workflows, overhead, evolving tech, etc. So like I said, my primary specialty is in the visualization spoke, but I have a depth of experience in each of the other areas through different roles I've held over the past decade. So today I'll provide a kind of a high-level conceptual introduction to vertically integrated manufacturing and prefab of light gauge steel panels and trusses. So I spent about a year with a light gauge steel manufacturer building a BIM workflow for kind of a vertically integrated manufacturing concept. So that meant engineering, detailing, fabrication, and installation was all handled under one umbrella. And this provided a very interesting opportunity to leverage BIM across multiple stages of the typical project lifecycle. So BIM played a crucial role in streamlining the process by functioning as the primary tool for authoring and tracking fabrication data. So the vertically integrated concept kicks off with engineering via design and documentation, which is a pretty typical place for the structural phase to begin. So structural design marks the start of this manufacturing process and kind of sets the tone for the remainder of the project lifecycle. So for those of you who have worked with light gauge steel before, the first step is outlining the requirements and various light gauge steel components. So to dive a little deeper, vertical integration in this context means that as structural details are developed, they're actually directly informing means, methods, and materials. So this is very different than traditional project delivery, where liability exists in silos between A, E, and C. And there's limitations on how detailed the instructions can be during a handoff from one party to the next, which is often through kind of general typical specs or generic details. You often hear architectural drawings are just referred to as, diagrams. The contractor is responsible for actual means and methods. So In this case, there's a major divergence from traditional process, which will start to become clearer as the engineering progresses. So this is an image of a wall panel, and it's just a small sampling, but it does show several different components integrated under this umbrella. So you have your stud gauge and sizing, so your profile sizes, 18 gauge, 20 gauge, etc. Stud spacing, which is 24 inches on center as shown. Horizontal bracing, midspan of studs. Your king studs, which they can change depending on structural loads. Shown here, they're double kings. The header configuration, sizes, gauges, and another seemingly small but significant item for coordination, especially at this stage, is actually pretty easily handled in BIM. And that's going to be trusses bearing directly on top of vertical wall studs. And that really helps improve the structural quality and performance of light gauge steel. So structural details being modeled in parallel with documentation not only helps ensure more completely engineered structure, but also tees up the next stages of development. So the next step in the process is usually truss design. And there's a multitude of ways the industry approaches this stage, but typically it's handled by an independent truss supplier. But that's not the case with vertical integration. So this example shows long span trusses for a sloped roof. They're designed, detailed, and prepped for fabrication in the same model that was used for early engineering. Some truss design tools inside of Revit, things like MWF Truss Designer, can give real-time feedback on configurations. So quantities can be extracted and used for estimating, ordering raw materials. Mechanical clearances can be incorporated into truss designs and provide downstream coordination benefits. Direct feedback on load paths and how it's going to impact wall panels. And some other benefits, so like considerations made during the design process of the trusses can be carried forward all the way to fabrication and even installation. So that helps reduce information loss thanks to the elimination of handoffs to third parties or independent suppliers. So the consolidated liability, engineer, manufacturer, installer roll into one, allows means and methods for prefab to be explored virtually with installation crews prior to delivery on site. So the example here is a two-way cantilever truss condition. So even complex situations such as this can be carefully thought out and designed in a controlled environment. So by designing trusses in place with the BIM model, there's a high amount of efficiency thanks to real-time feedback against the architecture model. Things like fascia depths, overhangs, slope, etc., things like that. So uncommon and unique conditions can be vetted to ensure problems during installation are minimized. So after design and engineering, the next stage is detailing and coordination. This is the stage where you start to see the compounding benefits of this vertical integration. So BIM models now have trusses and framing modeled per the engineering requirements, and they exist sort of as like a digital twin, except the other way that would normally be configured. So as most of us know, framing follows the actual construction. Framing will follow slabs and foundations. So traditionally, the lack of a framing model in BIM and the speed of this stage means coordination pretty much just doesn't happen at all. And issues are dealt with as they arise in the field, or things are constructed and you backtrack, kind of repair and replace. So by marrying a scan slab with a framing model, you can actually avoid slowdowns during installation. So anyone who's been fortunate enough to kind of work with a scan of a slab or a concrete pour knows there's a number of issues that come up and that can be addressed. Things like floor flatness, plumbing and electrical stub-up locations. So this image shows the coordination between steel and plumbing. So you can see the plumbing stub-ups here. So most importantly, there's no conflicts with vertical studs. And like I mentioned earlier, studs are often aligned with trusses, so that can cause serious problems if they need to be modified or moved. Second, alignment with bottom tracks can be verified, which anyone who's dealt with framing kind of knows that can be a big issue. So you can actually see here, there was an issue with a sanitary main on the right, and that was actually crossing over the track, but it can be caught early before steel is complete and delivered on site. So another benefit is design and coordination of anchor bolts. So they're usually not considered to a great extent prior to construction in the field. So prefab of wall panels means there's very little room for error during installation, and a single misplaced bolt can cause some pretty significant delays, which negates the primary benefit of prefab, which is saving time. So to avoid issues, anchor bolt coordination can streamline installation. So usually risk of advising on means and methods, that's where that would come up with anchor bolts, but that's effectively eliminated due to vertical integration. So the exact locations of bolts can be specified. Something like using screw anchors can reduce coordination between slab pours and framing installation. So that's typically a pain point with cast in place anchors because they can conflict with vertical studs and door openings. So that would be a situation where field modifications would be required, which again slows down construction and or could impact the quality of construction. Extremely tight tolerances can be achieved, as tight as 1/8 of an inch. Hold down locations can be anticipated and identified well in advance. And the stud tracks can be pre-punched at each bolt location, which eases the process of mapping out bolt locations in the field. So throughout the BIM process, Dynamo plays a very important role. For those of you who are already familiar with it, you already know that the possibilities and use cases can pretty much seem endless. So in this particular case, I was used in a few key ways, such as expanding the functionality of Revit plugins, such as MWF, and improving their integration and communication with Revit. Used to generate CNC files, data mining, large volumes of data from the 3D assets, which can be used for estimating, material takeoffs. And my personal favorite, automating the placement of anchor bolts and communicating with MWF to generate service holes. So Dynamo is definitely an important tool. So
You're here.
So design technology keeps improving, providing us with new tools. So I'm sure we're going to see an evolution continue in manufacturing as that starts to catch up and learn how to use a lot of the tools that exist in AEC. So that wraps up my introduction to BIM and manufacturing. So hope you guys enjoyed it. And any questions?
Very much enjoyment happening. I will tell you from the chat happening. I don't even know how to sum it up, to be honest. And not necessarily even you, maybe even Steve or Scott, if you want to add into this. It seems like there's a lot of discussion in terms of, maybe I'll get to that in a second. Let me get to the more pointed ones. Can Fabrication use this application to develop their shop drawings?
Yes.
Let's start there. Yes.
Yep. Absolutely.
We had a question that from David, who asked, we use cast in place anchors for our curtain wall all the time. Does this become an issue with other trades?
That's where at least being part of the discussion, it puts it out in front. So now it can be discussed and planned for accordingly. So kind of broad stroke, taking a different approach because construction and engineering are all kind of in the same team. That's where trying to find a different approach to anchors, either through an epoxy bolt, if you need something that's kind of added after the fact, that can really improve that coordination of bolts just to kind of minimize and make sure everything slips and locks into place.
And I love that you're thinking about that, you know, how everybody on the team is affected. So that's really important. Do you have any data on how much labor does it save compared to the traditional coordination process?
That's a good question. It's always hard to quantify because it's kind of rolled all into one process. So it's happening just kind of as design documentation and detailing is running. So I don't have an exact number on it, but I would have to imagine it's fairly significant. And being an architect, I've always tried to take that approach of trying to think through construction while working because then that helps kind of minimize any required downstream coordination.
How do you deal with field fixes?
Traditionally, just kind of the same way you would anything else. But having structural engineering on the team, that gives you the opportunity that if a unique fix is required, or it's a very tricky situation, you at least have the right people in place to kind of think through and develop a solution that can be structurally approved and blessed for the field.
So getting to the bigger topic at hand, it seems like there's a giant discussion here within the chat about, really it comes down to the level of detail that we typically provide in construction documentation and the scope of our work. And maybe Scott, this would provide a perfect segue into your presentation, or even just to a larger conversation. But can you talk to that a little bit? Like, where does that line fall, right? Like, typically as structural engineers, architects, we're not, for many reasons, going to be modeling to that detail, right? Mark threw in there like, oh my gosh, I can see the Revit model getting bigger by the second. Not to mention the liability side of things. So can you talk a little bit to this process and this integrated approach?
Sure. Yeah. So that's actually been something in the forefront of my mind. Being kind of recently licensed, going through that whole process, learning about much on a deeper level about liability. But I've seen that pretty much the entire time I've been involved with BIM, that there's really a limit. And that's why I kind of referred to it earlier as silos. The A, the E, and the C, it's so heavily partitioned. And the way the contracts
to the owner and the use
absolutely
of the building, the maintenance,
and the way contracts are written, the way liability splits are, just even the traditional construction process. Even though we think we've made leaps and bounds with BIM, really, if you break it back down to the contracts and where the lines are drawn, I think that's truly right now in today's day and age the biggest limitation on BIM, because architects, even structural engineers, it's kind of a limitation on how much you're going to put in BIM, because at the end of the day, you have to consider profitability, and you can't just do things for the sake of doing them because they're interesting. So the project would have to be structured from the get-go with contracts and liability to kind of work with this new system. So rather than architects and engineers providing diagrams for the contractor to build, and I've worked in the general contracting side as a coordinator. So I've also seen in the other end, taking the diagrammatic models and turning them into real models based for fabrication. Just at disconnect, there's so much inefficiency, but it really all stems back to the liability and the way the contracts are drawn. So I think once we see a big evolution in the liability side, that's when I think we'll see real changes in how BIM can actually be used, and we can start pushing the limits on efficiency and kind of cross-pollinating between disciplines.
And kind of this idea of the model being the deliverable in some way, right? And like this idea of almost a digital twin as you're going through design, but also through construction, and informing that model back about what's actually happening, and then thinking about how maintenance and the building owner can utilize this data later.
Exactly. Yeah. Digital twin would be beautiful. It's a beautiful concept, but because of that liability split, we just can't quite get there.
Exactly. That is a presentation in and of itself.
It certainly is.
Well, thank you so much for your time, Dan. And of course, please feel free to throw additional questions as they come to you, and we'll have a chat at the end.
Excellent.
So certainly not least, but we have Scott last. How's it going, Scott?
There we go. Fantastic.
There we are.
I can work Revit better than my headset and mute
button. I am right there with you. With all of these audio devices, I have no idea what's going on with all of the different apps and portals that I have to communicate in. How are you doing today?
Doing wonderful. Thanks for having me. And man, the in conversations that were going on right there, like I could just change gears and talk about that for like 20 minutes, but I don't want to. But I'll just kind of say that, to Dan's point, the line is really graying between engineering and fabrication. or blurring, I should say, between the two. And, I've got some really impressive clients that from an engineering standpoint are starting to do a higher level of detailed design, more on the MEP side. That's what I focus on. And I won't mention company names, but it was a great kind of quote from a COO from one of those MEP firms. And he said, basically, our feelings were hurt that our models were getting thrown away. And so, because just think of a conceptual model is basically what the mechanical contractor is thinking of the engineer's model. And so when they were getting that, it was like, yeah, we're not going to use this and throw it out. So yeah, the COO said that hurt my feelings. So we started thinking about ways as a company that we could do better, and enhance our deliverables. And does that cost more? Obviously, right? Because you're doing things that you might not do in the past. In some cases they are doing hangers all the way down, but that's pretty extreme. But it's really just finding that sweet spot as far as that value add that you're adding back to the owner at the end of the day and getting selected on jobs and projects. But there's definitely a learning curve because going from a design model into a fabrication model, there's definitely some differences. And if people haven't done it before, they just don't know how, right? So
yeah, I mean, not only are the building models not getting utilized necessarily. I had a conversation yesterday where it's our contractors are in some cases asking for PDFs or DWGs, and like you said, not even ever touching the red model or requesting it at all.
Right.
So yeah, it's kind of disheartening. I'll say disheartening for us as people who work so hard on these models and incorporating all of this data into the model. To pull this stuff from Dynamo to, all of these wonderful computational tools and things like that. And then for it to just get tossed to the wayside.
Scott and Dana, may I add something?
Please.
Yeah.
I'll say this, since we've become a software company, I see Europe and Asia really leading the way for this right now. There's
100%.
much more of a collaborative effort to coordinate for the owner versus to coordinate for the individual trade. You also see a lot of big companies becoming vertically integrated as well because of things like this. I think we're starting to see the importance of it. And there's actually a drive by government standards. If you do submit a digital twin, there are financial benefits for either owner or who, I'm not sure who the money goes to, but there are financial benefits for modeling in BIM, at least as of this last year, out in UK and other places. Singapore is definitely also leading the way, I think. We're getting there. I don't think we're far. I think we're starting to see the benefits. It's always nice to be the second winner anyway, right?
Let them work out the kinks
exactly.
of it, right?
So,
yeah, I mean, modular over there was a way of life, modular construction and everything. So it was nothing new overseas. It's newer here. So they've got a lot of principles in play, and we're trying to leverage that as a company, at Autodesk, and and how we can do better. And even along the same lines of what's new from a fabrication standpoint. I wasn't really going to talk a whole lot about that. I've got some others that relate to it, but because the topic is so relevant, if we do have design-based content and then we've got fabrication-based content, those are two different things, right? On the design side, I care about CFM, GPM. On the fabrication side, I care about it's a TDC connector or slip and drive connector, and it's galvanized 18 gauge or whatever. So there's key differences between it. But something that is exciting that we're doing and have been working on it for some time is, if you've been using our MEP fabrication tools, you'll know all about the database and all of that, and you're building your content libraries. So we are in pretty advanced beta. It's public, somewhat open in some capacity for our fabrication data manager. And so essentially that's taking that fabrication content, so your pipe specs, for example, your valves, et cetera, and putting them in Forge. And so if you think about that from a functionality standpoint, it's like, okay, well, that doesn't make me draw slope piping any better. But you're absolutely correct. It doesn't make you draw slope piping any better. But if you think about like the grand scheme of things, for us to be able to get our content there, it makes it much more accessible. Whether that's on Steve's behalf or Dan's behalf, but it's getting that data in a very accessible location. So from that standpoint, really opens up the doors. And it's kind of like with Revit. I started with Revit Systems 1 in 2005. There wasn't even a pipe tool in the first version of it. But for those that used Revit early on, is like, if you used AutoCAD or AutoCAD MEP or something like that, you used it and it was like, man, this is brutal. To me, the first time I used Revit, I felt like I was using Paint, MS Paint. I felt like I didn't have any precision or anything like that. And it was just like insane. But it wasn't long before I was like, I get it. I see that it's not about the 3 tasks I do all day long. It's about start to finish, and I think it would be hard for, extremely valid arguments to say that Revit isn't the best platform for a start to finish type of approach. Now, obviously, are we handing it off into some cloud technologies and some add-ins and partnerships? Of course. But as far as a platform standpoint, that's what we're really excited about to enhance that as well. So to spin that big circle back into my actual presentation, what I'm going to talk about in these next 10 minutes is how we can basically enhance some of the model coordination side of things. So obviously, drawing fabrication parts, sure, that's one aspect of it, but such a big task that falls under us is going to be coordinating this stuff, right? I've got to coordinate my hangers with cable tray and everything else going on through there. So I want to talk a little bit about that because there are some new features as it ties into it. And so BIM Collaborate Pro is going to be one aspect of it. And this is one of those, if I've gotten this question 1,000 times in the past 3 months, but if you didn't know, Autodesk BIM Collaborate Pro is essentially BIM 360 Design plus Coordinate. So it went through a rebranding, Feb 1, as far as making those product changes and things like that, as far as the naming convention goes. But it's essentially that combination of those 2 platforms. And so what that starts to do is enhance our, coordination abilities. We were able to push things through into Navisworks, which we were doing that before from within the cloud, being able to access the models and kind of do some different things with those. So I'll talk about some new things there that's coming into play. And then also, if you hadn't seen those coordination issues or those clash issues that we generate, and any issue for that matter, now has an integration with Revit. And these are a big deal because this was all fixed last week to work in our new platform, our unified platform, and things like that. So from there, just kind of recap a couple additional features, and we'll open up for Q&A, and I'll try to be as quick as I can here. So this is, anytime I talk about model coordination, I kind of lead with this statement. So model coordination, so within BIM 360, Autodesk Construction Cloud, whatever, does not replace Navisworks. That's my awkward pause there. Like, that has to sink in. So because I get brought in, oh, that's Navisworks in the cloud. Absolutely not. Absolutely not. So like I put there, think about it. It's a supplemental tool to a Navisworks workflow. It opens the door for do some things on the front end. It's easier to use than Navisworks. You can learn it quickly and things like that. Just like a protein shake isn't supposed to replace everything you eat all day long. It's supposed to supplement. It adds to it, adds benefits, things like that. So that's one key thing. And the sooner you start looking at it with that lens, the better it becomes for you, because you're not trying to do the exact same things between them. So with that, I'm just going to jump right into it. All right, so I have a project set up in BIM 360. I've got fabrication models with fab parts in there modeled out. You can see I've got wonderful spool sheets, that are incorporated. I have an electrical fabrication model. It's faked, but I've got one to make stuff hit other things, which was my intention. So no different than what you would see in a normal project environment. If you're using, the Construction Cloud or BIM 360, you're going to have, your storage repository as far as where these files are living. Now, this is kind of a nice, we'll say, happy sandbox. Everybody's playing in it. We've got the architectural team, civil even threw us, some dirt around so we can put our building in there. But then it starts to break it off, right? And so when we talk about model coordination, it is, if you were unaware, it's just going to be, a module essentially that becomes activated for you. But there's 2 approaches to it. One being, you can essentially have it do some automatic clashing for you based upon, I'll say, a live folder. Now we know nothing in BIM 360 is really live because you have to publish, right? You have to publish something up there, but that's as close as it can get to live. Or what most people were used to, in that VDC role is kind of a snapshot in time, right? At 60%, 50%, 90%, we're going to perform, this clash and run it in there. Now, obviously, there's some that's, like I said, ongoing, but we support both of those workflows, right? Being able to come in and do that, I call it static just to be easy, and I call it live, to make it very clear there. So what I've done is I've set up what are called coordination spaces, and those look at a defined folder location for me. Now, these can be titled anything because, again, this is one giant sandbox. Everybody's playing in it nicely. So even the structural, fabricators can have their own coordination space. And what that's doing is looking into a folder that I've defined in my document management side of things. And you can see my mixings of a little bit of everything else, through time there. So I get to point to where that's going to look to basically, start to aggregate those models for me. And if I were just to kind of drill down, if I looked coordination, I had a folder called VDC, mechanical 90%. And what that's going to do is scan those Revit models. What is very interesting about this is if you haven't seen it before, it will automatically extract the 3D views from these models for us. So if you think about your Navis workflow in Revit, for example, most would have 3D views in their template set up, sheet metal only, piping only, structural only, whatever. And they would export those to NWC files, and then they would aggregate those inside of Navisworks. So this is essentially automating that view creation for you, which is nice. So that way it's already going up there and you've got that control. So it's going to scan these. And again, they're not live. I've copied them over there. That's why they're all V1 for now. So what that's going to look like in our model coordination environment is I'm able to choose what that space is I essentially want to work on, right? And then here's all of those 3D views that are extracted out. So let's say we wanted to do, what's going to hit today? Let's go sheet metal, and we'll go cable tray. So I'm going to pick those two views because that's all there are. There's Revit views, and I'm going to take a look at them. Now, that project doesn't have it set up, but the ideal workflow would be you would have your 3D view set up in your Revit project like level 1 cable tray, level 2 sheet metal, level 3 piping, and all that. So that way you can pick those check boxes of those views that aggregate those on a floor by floor level, right? So what that did is it pulled them together for me. That's great. We see them in there. Here's our Forge viewer, fun to look at things inside of, easy to navigate. But what I'm going to do before anything is I'm going to say, hey, I don't want to have to check that box every time, right? I need to be able to pull that up quickly, especially if there was like 6 or 7 of them that I was, again, aggregating together. So if I did cable tray, sheet metal, and you can put notes, descriptions, all that fun stuff. You can make them viewable to everyone else, but I'm just going to leave them private for myself. So again, that's going to be quick and easy to pull up later on. Now, if I look at what this is doing from a clash standpoint, here's our automated clashes that are taking place. Now, it's going to look at a primary model and a secondary model in there. All that's doing is controlling the hierarchy, right? So it's putting from the fab model, which is all ITM content, it's putting the items at that top list. If I were to switch those, that's just making the parent being the electrical, and then I can look at it, okay, well, it's cable tray, and so on. So it's your control. You can add models after the fact, no big deal. You also have a little bit of filtering we can do. So if I want to say, hey, I want to find every one of my air handlers that's getting hit by something. Now, if you're a Navisworks user, this would be 15 line items on a clash report going down through there. You would have to manually group those together. This does automatically group them, right? So it does have them all spelled out and kind of pulled together. So that's kind of nice that it's doing that.
I'm kind of surprised that it at this point doesn't pull the levels separate from one another.
Yeah, I mean, we get the Forge viewing, right? So you can slice it up from a viewing standpoint there, but yeah, it needs that. You control just like you would that NWC file.
Right. So just like your Navisworks views, right? We're
Yep.
going to just set up our Navisworks or our 3-dimensional views with just what we want to see
Mhm.
in those views. And then those are what gets coordinated across.
And maybe that's vertical. I mean, because obviously 3D views
The
are
wing of the
easy.
building.
Yeah, it could be a
or what
wing, a
have you.
mechanical room, area A, area B, whatever it needs to be. But yeah, if I looked at those, hey, there's the clashes. We see them. their goal was to try to go through the center of every air handler with their cable tray apparently, but they even got that incorrect. But we can see, hey, we've got clashes, right? So at this point, there's a couple approaches. Like I could do this high level clashing right here and generate an issue with it and say, hey, this needs to be resolved. Definitely, right? Because we've got 2, 4, 6, 8, 10 or so, air handlers getting hit there. So if I were to create an issue, it's going to categorize it for me, give it a title, HU, and tray. Again,
thinking about what, tying all of these presentations together while we have a minute left.
Yeah.
The bounding box that was talked about with Dynamo, right? Scope boxes was brought up, Ryan, but you could also use bounding boxes to, separate your wings. And
yeah, that could divide them out. Absolutely.
To, populate values and such. Now, we are super respectful of everybody's time. Scott, thank you so much. That was so awesome. And I'm sure we can find tons of information about this as it comes along. So before you leave us, could you pick a winner? $50. You got a lot on the line.
Yeah, let me go. Participants.
And while you pick, Dan has picked Simon. So congratulations, Simon and Mark, so far. Scott will pick
Hold on.
our third.
I'm moving my finger up and down the participant list. Touch my screen. Carol Larson.
Okay, there we go. We got to get a girl in there. Well, thank you all, 3 of the presenters, for presenting today. You guys do have their information. This recording will be posted up on LinkedIn. We'll stay on here a few minutes. If you guys have any questions, I'm more than welcome to stay. Thank you all for joining us today on BIMxt Network. All right. So yeah, it looks like we covered pretty much all the questions. Doesn't look like we have anything coming up. But no, I thought, Steve, that was a really wonderful point that you made about Europe, right? The BIM pyramid. And I think that they're actually very, very advanced in this leadership thought on BIM, and not necessarily what we do, but what we should be doing, right?
90% of our customers are in Europe and Asia.
There we go.
And because our tool kind of forces workflows that not everyone's comfortable with here. Hey, Scott, can I ask you a random question? Is Element ID being used to collaborate between these 2 platforms, or what?
Element ID, and it's also doing the SVF loader. So like basically what Navisworks does to make things super lightweight.
Okay.
So we're doing it kind of both. That's what the object is, but it's still retaining that Element ID. And that's so that's why like we support IFCs in model coordination, but not from all products.
Yeah,
like
because
Tekla,
it's not. Yeah,
it's not. When you get it from some of the other programs and it rewrites the IFC, it rewrites the Element ID. It's not a constant GUI.
Yeah, right. Which is always hard to keep consistent, from what I understand. In any program, really. But okay.
Yeah, so that's why like Revit, ArchiCAD, Tekla, and a couple others we support right now.
Okay, cool. Thank you.
All right. Well, it looks like that's about all we have. Don't forget to fill out your survey. Allison will definitely get that sent out to you guys. You can win a gift card next month. So the chance is not yet over. And congratulations, BIMxt. We've made it a year. Make sure you join our LinkedIn group if you have not already. So thank you all. And if the presenters, if you have a moment, we would love for you to stay on. Everybody else, thank you. Have a wonderful day.